All right, last practice example on the application of Le Chatelier's principle. Here we have N2O4 in equilibrium with its dimer, or the dimer N2O4 in equilibrium with two molecules of NO2. And written in this direction, the enthalpy change, standard enthalpy change, delta H, is equal to 57.2 kilojoules. The important part of that information is that this reaction is endothermic. In other words, I need energy basically as a reactant for this reaction to occur and to reach equilibrium. So if this reaction is at equilibrium and I increase the temperature, what would be the effect? If I increase the temperature, that's like increasing a reactant. And when I add a reactant to an equilibrium mixture, then that drives the reaction forward. And so the question says, will the NO2 formed from this reaction, will that amount be greater at a higher or a lower temperature? Well, for an endothermic reaction, if I perform an endothermic reaction at a higher temperature, that drives the equilibrium forward. And so therefore NO2 formed would be greater, that amount is greater at a higher temperature rather than a lower temperature. And that's because this reaction is endothermic.